This is 8th grade lesson 5.3. In this lesson, students will use a formula to find the missing angle measure of a polygon. The standards covered in this lesson are 8G5. The page numbers out of the hardcover book are pages 196 through 202, and out of the practice journal, pages 103 through 106. Okay, we're going to review really quickly some of the stuff that we did in the activity for this lesson. In the activity, we learned that a polygon is going to be a closed figure that is made up of 3 or more line segments that intersect only at their endpoints. So here they're giving us 3 examples of polygons. So once again, if you look, they all have straight lines, okay, no curved sides. They all are an enclosed figure. Okay, so when we compare that to non-polygons, well, what eliminates them? This is enclosed, but we have curved lines. So that eliminates it from being a polygon. Once again, this one is also enclosed, but does not have straight edges, so that also is no longer a polygon. The next one looks like it is enclosed, which it is. It also has straight sides, but what eliminates it from being a polygon is the fact that it's actually 2 triangles. So it's really 2 polygons. Okay, so it has to, you can't have where there's that closing there. It actually created 2 polygons. So in and of itself, just being a polygon would be eliminated out. It would actually be 2 polygons that are just attached to each other. Okay, we also reviewed in our activity what a convex polygon is and a concave. And convex is where you're going to have all of your vertices actually point outward. A concave polygon is going to cave in on at least one of the sides and have at least one vertex that is going to point inward. So for example, this would be a convex because all of them point out. These 2 would be considered concave because see how this points in towards the inner part or caves in? And same thing here. This vertex caves in or points. So this would be a concave because it caves in, or those 2 would be considered concave polygons. So we're going to actually be working with those 2 concepts that we did in our activity just to kind of review through the information that we did in our activity for this lesson. Okay, so here's our first example. It says find the sum of the angle measures of each polygon and identify if it is a concave or a convex polygon. So what we need to remember is from yesterday, we found out that if we knew the number of sides, we could subtract off 2 and then multiply by 180. So here I have a 3-sided figure. So if I took 3 minus 2, that gives me 1, and then took that times the 180, it gives me 180 degrees, which we already know that about a triangle, so we wouldn't need to use that formula to figure that out. We know that a triangle equals 180 degrees. This formula is going to help us go through and actually work with some larger sized, or larger in number sides polygons. Okay, so let's go ahead and look at this next one. When we count the number of sides, now I'm one that likes to go through and actually touch each side, so I tend to mark it 1, 2, 3, 4, 5. So there's 5 sides. So our formula is we're going to take our number of sides, which was 5, minus 2. Okay, so when we do that, we get 3, and then we're going to take that answer times 180. So if I take 3 times 180, that gives me 540 degrees. Okay, the other thing that we want to identify in practice is this a concave or a convex polygon? So when we look at each of the corners, they're all pointing out. None of them are pointing inward or caving in, so this would be a convex. Okay, as soon as you have one of your sides cave in, then it's considered concave. Okay, so we have a 4-sided figure, so if we do 4 minus 2, and if you want to do the triangle part, that's fine. It's just that concept is not always going to work or be easy to use. But we know there's 4 sides. And if we subtract off 2, because that's our formula, so 4 minus 2 gives us 2 sides. So now we're going to take 2 times the 180. 2 times 180 gives me 360 degrees. So this is a 360 degree angle or degree polygon. Okay, so now if we go through and decide if it's concave or convex, looking at the vertices, they all point out all of them point out. So this would be convex. Okay, as soon as you have one that caves in, then it's considered concave. Okay, so here, this one's got lots of sides. So if we go through and we mark each of the sides, I like to mark them because I'm always afraid that I'm going to miss one of them. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon, 8 sides. So our formula is to take our number of sides, 8 minus 2, which is going to give us 6. And then we're going to take that times 180 because that means there's 6 triangles that make that up. So let's see, 6 times 180. When we do that, we get 1,080 degrees. So it's a 1,080 degree figure. And all of the vertices point outward. So this would be, again, a convex polygon. Okay, so I want you to try these next two. Oops, wrong one. Okay, so go ahead, pause your video, and work your way through this one. I want you to find how many degrees are in that polygon using our formula of the number of sides minus 2, and then taking that answer times 180. And then I also want you to identify if it's considered a convex or a concave. So go ahead and pause your video and you'll work your way through these two, and then check back to see your answer. Okay, so on this first one, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 2 is going to tell us our number of triangles, which is 7. So we'll take 7 times 180. And when we do that, we get 1,260 degrees. And all of the corners point out. So this would be a convex. Okay. On our next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 10 minus 2 is going to give us 8 triangles that would make that up. And then we're going to take that times 180. So 8 times 180 gives us 1,440 degrees. And here we have where it caves in on multiple sides. So this would be a concave. Okay, so that's working with that formula of S equals our number of sides, or N as what they often use. I noticed on STAR that they tend to give you that formula. So your number of sides minus 2, which tells you how many triangles are in there, and then we take that times 180. Okay, the other thing we're going to work with in this lesson is what they call a regular polygon, and then we're going to be solving for a missing side. So a regular polygon is going to be a polygon where all sides are congruent, that means equal to each other, and all angles are congruent. So these are some examples of regular polygons. So what they mean is all of these sides are the same length. Okay, all of these angles are the same angle measure. Okay, if we know that, then we can go through and actually find any one of them. So when it's regular, that means everything's equal to each other. So it says, would a rectangle be considered a regular polygon? If I were to go through and actually draw a rectangle, let me just grab up here a rectangle. Does it meet the qualifications? Well, it has to be all sides are congruent. Is this side right here the same length as that side? No. So a rectangle would not be considered a regular polygon. Yes, all of the angles are equal, but not all of the sides are equal. So here it says, find the measure of each angle of the above triangles. So we're going to use the information that we had on our previous slide, and we're going to find the angle measure. So if we go through and count the sides, 1, 2, 3, 4, 5. 5 minus 2 would give us 3 triangles, and we're going to take that times 180. So if we do 3 times 180, that gives us 540 degrees. Now, if every angle measure is equal to each other, That means I can now take this 540 and divide it by the 5 angles that are there. 1, 2, 3, 4, 5 angles, right? So if I divide that by 5, it's going to tell me what each one is worth. So 540 divided by 5 gives me 108 degrees for each angle measure. Whoops, and then I'm going to write 180. So 108 degrees for each angle measure, meaning each of these is 108 degrees. Okay, the only time this works is on a regular polygon. So there I have a triangle. We know a triangle is 180 degrees. So I have 3 angle measures. Remember, it's regular, which means they're all congruent or equal to each other. So if we take 180 and divide that by 3, it gives us 60 degrees for each of these. Okay, so let's do the square that's there. If I do the square, well, we've got 4 sides. So we've got 4 minus 2 gives us 2 triangles in there, times the 180 gives us 360 degrees. Now if we divide that by the 4 angles that are there, so divide by 4, that gives us 90 degrees. And I know you guys all know that a rectangle or a square has a 90-degree angle measure, but this is just practicing that concept. So I want you to go ahead now and use that concept to solve for this one. So your first step is to find how many degrees are in there, and then go back and count how many vertices are there. 1, 2, 3, 4, 5, 6. So you're going to divide your answer, your sum, by 6. So go ahead and pause your video and work your way through that one. Okay, when you do this, you should have ended up with 120 degrees, because we would take 6, the number of sides, minus 2, which would be 4, so there's 4 triangles, times the 180 gave us 720, and then we divided that by the 6 sides that are there. And we ended up with 120 degrees for each of these angle measures. Okay, so that's working with a regular polygon. Now we're going to go ahead and finish out this lesson by working with polygons that aren't considered regular, but where they want us to find a missing angle measure. So we have to kind of tie in things that we have learned previously. So in order to solve this, first of all, we have to know how many degrees are in this 4-sided figure. So if we take 4 minus 2, that gives us 2 triangles. So 2 triangles times the 180 is going to give us 360 degrees. Now, we know that has to equal 360. So we're now going to subtract off everything that we know. Now, if you want to go through and add up what you currently see for degree measures, remember this is the same as 90 degrees, you can add them and then subtract from 360. But what I tend to do is I leave the 360 on my calculator and then I subtract off the ones that I know. So I'll hit minus 115, and then I'll just keep that answer on my calculator, minus the 180, and then minus the 90 degrees. If you want to add these together and just subtract once, that's okay also. So if I take and have 360 on my calculator, minus 115, minus 80, minus 90, that leaves me with 75 degrees for x. Okay, so I now know that x is 75. If I want to check it, I can add together each of the angle measures. Okay, so let's try another one. Okay, so first step, we need to see what our sum would be. So I've got 1, 2, 3, 4, 5, 6 sides. So if I take 6 minus 2, that gives me 4 triangles. So I'm going to go 4 times 180. 4 times 180 degrees gives me 720 degrees. So I know that they all equal 720. Now I like to go ahead and just subtract off what I know. If you want to add all of these together and then subtract them from 720, that's okay. I'm going to go ahead and just do 720 and subtract off the ones that I have. So minus 125, minus 120, minus 125 again, minus 110, minus 135. When I do that, it leaves me with this to be 105 degrees. Okay. All right, so I want you guys to try this next one. So it's tying in two things that we have learned. Okay, so go ahead and try this one. Go ahead and pause your video. Here's the key thing, is when you get to the end of this one, remember this is the number of x's they do want you to solve for x, okay? So go ahead, pause your video, and work your way through this equation. Okay, so this one was kind of complex. I was actually giving you one that was a little more advanced. But here, if we had to go through and figure them out, we knew that each of these was actually, we could find out that those were each 70-degree measures. But usually when they do this, they want you to solve for x. So I added together the number of x's that we had, which was 4. That's where I got my 4x. Okay, I had 140 degrees left over, so we split that by 4 or divided it by 4. We found out that x equals 35, or each of those degree measures was 70 degrees. Okay, so that's working with finding a missing angle of a polygon. So the key thing to remember is polygons, if they're regular, all of their sides are equal, as well as all of their angle measures. So these last 3 that we worked with were not regular polygons. To find the missing angle of a polygon, you have to find, first of all, how many triangles would make that up. So count your number of sides, subtract 2, and then take that answer times 180, and then subtract off the information that you know. So subtract off the angle measures that you know, and what's left over is what that angle or those angle measures would equal. Good luck with this, and just keep plugging away.